If I want to read the state of a push button like this one using my digital input pin, in this case pin number 7, then I need to have some kind of a circuit that will control what voltage pin number 7 sees. I've got a ground connection that's always at 0 volts and a supply voltage that's always at about plus 5 volts, and pin 7 can tell the difference between 5 volts and 0 volts. So I'd like pin 7 to be either 5 volts or 0 volts, depending on what I've done with the push button. Well, to get that to happen, I could connect one side of the push button to ground and connect the other side of the push button to pin number 7. And then if I push the button, every time I push the button, pin 7 would be connected to ground, and I'd be at 0 volts on pin 7, so I could be sure that pin 7 was at 0 volts. And that would work okay, except that when I wasn't pushing the button, I don't know what voltage I'll have on pin number 7. I'd like it to be 5 volts when I'm not pushing the button, so I need to somehow connect it to the 5 volt source here. And it has to go to 0 volts when I push the button, so there has to be a resistance in between. This is called a pull-up resistor between the 5 volts and pin 7. So if the push button is open, pin 7 will definitely be at 5 volts because eventually enough current will flow through to bring this up to a 5 volt potential. If I close the push button so that current is flowing across here, the resistance here is some resistance, and the resistance over here is essentially pretty close to 0 ohms. So the result is that this will be very close to 0 volts, and I'll read a 0 on my push button. So this use of a pull-up resistor lets us be sure what we're seeing on pin 7. This push button is plugged into the breadboard so that the contacts on each of the 4 corners are going into different rows. If I set my multimeter on continuity, then it'll beep whenever the leads are touched together. So if I plug this lead into that pin and this lead into that pin, I get continuity because those 2 pins are attached to each other all the time. If I plug that lead into that pin and this lead into this pin, I only get continuity when I press the button. I'm going to connect this pin to ground, and I'm going to connect this pin to plus 5 volts through a resistor. And what I should see now is when I make a measurement on the 20 volt DC scale between ground and the state of the push button, I've got 5 volts now. When I push the button, I go down to almost 0 volts. I release the button, I go back up to 5 volts. If I want to read the state of that button on pin number 7 on the Arduino, then I'll need to plug this lead into pin number 7 and also connect it over here to this side of the push button. And now when I press that button, pin number 7 will be grounded. When I release the button, pin number 7 will have 5 volts on it. When we read that pin with the statement digital read from pin 7, I will be equal to 0 if the button is pushed, making that contact there to ground, or I will be equal to 1 for not pushing the button, i.e. we'll get 5 volts if the button isn't pushed because it's connected through this pull-up resistor to the supply voltage.